Question 1. Given the circumstances, Mr. Thompson observes that a rooftop packaged air conditioning unit shows abnormally high discharge pressure. He notes the condenser coil is partially blocked by debris and the system uses R400 TINA refrigerant. What is the most appropriate immediate action for Mr. Thompson to take? A. Reduce refrigerant charge to lower the discharge pressure. B. Clean the condenser coil to restore proper airflow. C. Replace the compressor to prevent damage. D. Increase the condenser fan speed without cleaning the coil. Answer. Correct answer. B. Explanation. Cleaning the condenser coil addresses the root cause of high discharge pressure by restoring proper heat rejection. Reducing refrigerant could risk undercharging and poor cooling. Replacing the compressor is unnecessary and costly if the issue is airflow restriction. Increasing fan speed without cleaning does not remove debris and may not reduce the pressure effectively. Best practice is to maintain core cleanliness for efficient exchange consistent with HVACR inspection and preventive maintenance standards. Question 2. From a practical standpoint, Rodriguez is inspecting a ductless mini-split system installed in an older building. She notices frosting on the indoor coil while the system is operating in cooling mode. What is the most likely cause and how should she proceed? A. The indoor fan is running too fast. Reduce fan speed. B. The outdoor unit is overcharged with refrigerant. Recover excess refrigerant. C. Restricted airflow due to a dirty filter. Clean or replace the filter. D. The reversing valve is malfunctioning. Replace immediately. Answer. Correct answer. C. Explanation. Frosting on the indoor coil often indicates restricted airflow, which prevents proper heat exchange and causes the coil temperature to drop below freezing. While overcharging can also cause similar symptoms, airflow restriction is more common and immediately addressable through filter maintenance. Fan speed adjustments alone may not resolve the underlying restriction. A malfunctioning reversing valve affects mode selection. Typical frosting during standard cooling operation. Question 3. While examining a hydronic heating system in a commercial office, Mr. Patel finds that several terminal units are delivering uneven heat despite balanced pump operation. The system is a hot water loop with manual balancing valves. What should be his next step? A. Increase boiler temperature to force better flow. B. Adjust the manual balancing valves to achieve proper flow distribution. C. Replace all terminal units to ensure uniform heating. D. Install additional circulation pumps. Answer. Correct answer. D. Explanation. Uneven heat can result from improper flow through branch circuits. Installing additional pumps can provide adequate flow to remote terminals when the system design or existing pump capacity is insufficient. Increasing boiler temperature does not correct flow imbalances and risks overheating. Adjusting balancing valves is appropriate only if the system flow rate can be properly distributed, but may be ineffective if overall system pressure is inadequate. Replacing terminal units without diagnosing flow issues is unnecessary and costly. Question 4. Considering the evidence, Mr. Lewis observes that a split system's air handler exhibits unusual vibration and audible noise. Inspection reveals the motor is mounted with loose fasteners and the belt is slightly worn. What is the most appropriate corrective action? A. Tighten motor fasteners and replace the belt if necessary. B. Lubricate the motor bearings and ignore the belt. C. Increase fan speed to overcome vibration. D. Replace the entire air handler assembly. Answer. Correct answer. A. Explanation. Vibration and noise typically arise from mechanical misalignment or worn components. Tightening the motor fasteners eliminates looseness that causes vibration. A worn belt can exacerbate misalignment and reduce system efficiency, so replacement is appropriate. Lubricating bearings alone may not solve misalignment issues. Increasing fan speed can worsen mechanical stress. Replacing the entire air handler is excessive. Targeted mechanical corrections suffice. Question 5. In the context of an HVACR system inspection, Kim notes that a heat pump shows insufficient heating performance during low ambient temperatures. Outdoor coil frosting is observed, and the system uses a standard reversing valve. What should she recommend? A. Install a supplemental electric heat strip. B. Lower the indoor thermostat set point. C. Replace the refrigerant with a low pressure type. D. Reverse the reversing valve to cool mode. Answer. Correct answer. C. Explanation. Low heating performance during low outdoor temperatures can indicate that the refrigerant type or charge is unsuitable for ambient conditions, affecting coil heat transfer and frost accumulation. Using a refrigerant with a more appropriate pressure temperature profile ensures efficient operation. Installing a supplemental heat strip is a temporary fix and increases energy consumption. Lowering the thermostat does not resolve the heat transfer limitation. Reversing the valve to cooling would exacerbate the issue. Question 6. Under the assumption that Chen is performing a performance test on a commercial refrigeration system, he measures superheat and subcooling values that are significantly higher than standard ranges. Which interpretation aligns with these observations? A. The system is undercharged. A refrigerant needs addition. B. The system has excess airflow over the evaporator coil. C. The system may be overcharged or experiencing restriction at the metering device. D. Compressor speed is too high. Reduce up here. Answer. Correct answer. C. Explanation. High superheat and subcooling simultaneously suggest an overcharge or restricted metering device. Excess refrigerant increases pressure and subcooling in the condenser while restricting flow into the evaporator, causing superheat to rise. Undercharging would decrease subcooling and reduce cooling efficiency. Airflow variations impact superheat, but not typically subcooling. Compressor speed adjustments do not directly resolve metering or charge-related issues. Question 7. Taking into account recent developments, Walker observes a commercial refrigeration system with an electronic expansion valve (EVE) that oscillates frequently during operation. What is the most likely underlying cause? A. Improperly sized EVE, replaced with a larger valve. B. Erratic superheat measurement due to sensor misplacement or malfunction. C. Excess refrigerant in the system. Recover charge. D. Dirty condenser coil. Clean immediately. Answer. Correct answer. D. Explanation. Frequent EVE oscillation often results from downstream pressure variations or heat rejection limitations. A dirty condenser coil reduces the condensing pressure margin, leading to unstable superheat and valve oscillation. Sizing errors could affect performance but are not the most common cause in existing systems. Sensor misplacement may cause inaccurate readings but does not directly create physical oscillation. Overcharge alone may cause high pressures, but the oscillation pattern points to heat rejection issues. Question 8. While analyzing airflow in an office building, Mr. Davis identifies multiple supply registers delivering air at lower velocities than calculated, despite the fan operating normally. What is the most likely cause? A. Improper duct sizing or high static pressure losses. B. Leaking refrigerant lines causing cooling loss. C. Thermostat calibration error. D. Malfunctioning reversing valve in the heat pump. Answer. Correct answer. B. Explanation. Low air velocities usually result from ductwork issues like undersizing, excessive bends or leakage, causing high static pressure losses and uneven distribution. Refrigerant leaks do not directly impact airflow unless affecting fan coil performance drastically. Thermostat errors affect temperature set points, not air distribution. A reversing valve issue influences heating cooling modes, not airflow velocities. Proper design and inspection are critical for maintaining efficient air distribution. Question 9. As illustrated by a recent inspection, Nguyen finds a rooftop unit operating intermittently and tripping the high-pressure switch during hot summer conditions. The system is using R400 TINA and airflow across the condenser appears normal. What could be the likely explanation? A. The refrigerant charge is low. Add a refrigerant. B. The condenser fan motor is failing under load. C. The expansion device is stuck open, reducing system pressure. D. Outdoor ambient temperature is causing high condensing pressure. Answer. Correct answer. A. Explanation. Low refrigerant charge reduces heat absorption in the evaporator, causing the compressor to work harder and trip high-pressure safety switches as system pressures fluctuate. A failing condenser fan would show reduced airflow, not normal airflow. An open expansion device would lower, not raise, pressures, while high ambient temperatures increase condensing pressure. The issue is typically exacerbated by charge deficiencies, highlighting the importance of proper system refrigerant levels. Question 10. When analyzing a gas furnace in a residential property, Mr. Garcia observes yellow-tipped flames, soot accumulation in the heat exchanger, and HRConquer readings. Which action reflects best practice to ensure safety and code compliance? A. Just a burner air shutter to achieve a neutral flame and schedule maintenance. B. Increase the gas pressure to eliminate soot. C. Ignore minor soot as it is normal during startup. D. Replace the entire furnace immediately. Answer. Correct answer. C. Explanation. Yellow flames, soot and elevated indicating complete combustion, which is unsafe. Proper adjustment of burner air shutters and scheduling maintenance ensures complete combustion, protects occupants, and meets code requirements. Increasing gas pressure can worsen incomplete combustion. Ignoring soot is unsafe and violates safety standards. Furnace replacement may be necessary only if maintenance does not correct combustion issue, not as a first step. Question 11. Under the assumption that Mr. Carter is inspecting a commercial chilled water system, he notices the evaporator entering water temperature is higher than design specifications, while the leaving water temperature is lower than expected. What is the most likely cause, and what should he check first? A. The system is overcharged with refrigerant. It reduces refrigerant charge. B. The chilled water pump is circulating too quickly, reducing heat exchange. C. Airflow across the evaporator coil is insufficient due to dirty filters or blocked vents. D. The expansion valve is malfunctioning and stuck closed. Answer. Correct answer. D. Explanation. When the evaporator entering water is warmer than design while leaving water is cooler, it suggests a restriction at the metering device. A stuck closed expansion valve limits refrigerant flow, causing uneven heat absorption and inefficient transfer. Overcharging affects pressure and subcooling, but not this specific temperature profile. Excessive pump flow would reduce DT across the coil rather than cause this pattern. Airflow issues influence air handling units, not waterside coil performance. Question 12. From a practical standpoint, is Alvarez observes a EL-1 branch circuit is not delivering the expected cooling capacity, though the main unit operates normally. What is the first action she should take? A. Replace the indoor unit on the affected branch immediately. B. Check the branch piping for restrictions, leaks, or improper balancing. C. Increase the refrigerant charge to the system. D. Adjust the outdoor unit fan speed to compensate. Answer. Correct answer. C. Explanation. When a single ERF branch underperforms while the main system functions, flow or charge issues are likely. Adjusting refrigerant flow through inspection of piping and metering devices ensures the branch receives adequate cooling. Replacing the indoor unit prematurely is unnecessary if the unit is mechanically sound. Increasing refrigerant indiscriminately can worsen system imbalance, while fan speed adjustments correct branch level flow issues without addressing the root cause. Question 13. Through careful analysis of a residential split system inspection, Mr. Brooks notices that the compressor cycles on and off frequently within short intervals, and the suction line shows significant subcooling fluctuations. What is the likely underlying cause? A. Low refrigerant charge or a minor leak causing short cycling. B. Dirty condenser coil reducing heat rejection. C. Thermostat location causing false temperature readings. D. Faulty reversing valve operation. Answer. Correct answer. D. Explanation. Frequent cycling and fluctuating subcooling indicate the system cannot stabilize pressures, often due to a faulty reversing or metering device that affects refrigerant flow. Low charge typically reduces cooling capacity but may not cause rapid cycling alone. Dirty coils influence pressures but not necessarily short cycling patterns. If airflow is sufficient, thermostat placement may affect comfort but does not explain pressure fluctuations within the refrigeration circuit. Question 14. As demonstrated by a recent inspection, finds a rooftop unit's economizer is not providing free cooling during mild outdoor conditions. The dampers appear functional, but temperature sensors read inconsistently. What is the best next step? A. Replace the economizer completely. B. Calibrate or replace the temperature sensors to ensure accurate readings. C. Manually adjust the dampers to force economizer operation. D. Increase refrigerant charge to compensate for lack of economizer cooling. Answer. Correct answer. B. Explanation. Economizers rely on accurate sensor readings to modulate dampers for free cooling. Inconsistent temperature sensor data prevents proper economizer operation. Sensor calibration or replacement restores functionality without unnecessary mechanical replacement. Manual damper adjustment is a temporary fix and risk system imbalance. Refrigerant charge has no impact on the economizer's ability to provide cooling as it primarily controls airflow. Question 15. When faced with an inspection of a gas-fired furnace, Mr. Hernandez observes soot buildup on the burners and co-readings are elevated above safe limits. What is the most appropriate immediate action? A. Adjust the burner air-to-fuel ratio and schedule thorough maintenance. B. Reduce gas pressure to the furnace. C. Replace the furnace immediately. D. Ignore the readings as occasional soot is normal. Answer. Correct answer. A. Explanation. Soot formation and elevated CO indicate incomplete combustion, often caused by improper air-to-fuel ratio. Adjusting burner settings ensures safe and efficient combustion, while scheduling maintenance addresses long-term concerns. Reducing gas pressure without proper adjustment may worsen incomplete combustion. Furnace replacement is unnecessary if maintenance and adjustments can restore safe operation. Ignoring readings violates safety standards and code compliance. Question 16. In the context of a commercial refrigeration system, Parker notes that the condenser fan operates continuously at high speed, yet the condensing pressure remains elevated. What is the best interpretation of this observation? A. The refrigerant charge is low, causing high pressures. B. The condenser coil is dirty or blocked, preventing proper heat rejection. C. The expansion device is oversized. D. The compressor motor is running too slowly. Answer. Correct answer. C. Explanation. Continuous high-speed fan operation with high condensing pressure often indicates that the system cannot reject heat effectively due to coil restrictions or improper sizing of components. In this scenario, an oversized expansion device could reduce refrigerant flow control, increasing pressures in the condenser. Low charge typically reduces pressures, not elevate them. Compressor speed affects flow but would not independently create high condensing pressure with maximum fan speed. Coil cleanliness must also be considered but is secondary if oversized devices exist. Question 17. During the process of inspecting a chilled water system, Mr. Singh finds that several air vents in the occupied space produce uneven temperatures. The pumps and valves appear operational. What should he check next? A. Duct sizing and air distribution. B. Balancing of the terminal unit flow rates. C. Water temperature at the boiler. D. Thermostat calibration. Answer. Correct answer. B. Explanation. Uneven temperatures, despite operational pumps and valves, indicate flow distribution issues within the loop. Balancing terminal unit flow ensures each zone receives appropriate cooling or heating. Duct sizing relates to air handling systems, not chilled water loops. Boiler water temperature affects overall loop performance, but not specific flow distribution. Thermostat calibration can influence occupant perception, but does not correct physical flow imbalances. Question 18. Considering the evidence is new and observes that a ductless mini-split system has intermittent frost formation on the outdoor coil, which reduces heating performance. The system is operating in heating mode at low outdoor temperatures. What is the most appropriate corrective step? A. Adjust the reversing valve to the cooling mode. B. Inspect the defrost cycle and controls for proper operation. C. Reduce the indoor fan speed to prevent frost accumulation. D. Recover refrigerant and replace with a low pressure type. Answer. Correct answer. A. Explanation. Frost accumulation on outdoor coils during heating is common in low ambient conditions, and proper defrost cycle operation is essential to maintain heat pump efficiency. Checking and ensuring the defrost controls operate correctly prevents performance loss. Switching to cooling mode would exacerbate heat loss and is inappropriate. Indoor fan speed adjustments do not influence frost on outdoor coils. Refrigerant replacement is not typically required unless pressures are outside recommended ranges. Question 19. While evaluating an air handling system, Mr. O'Connor identifies that the return airflow is lower than design, causing negative pressure in occupied zones. What is the best action to correct this situation? A. Inspect for blocked or undersized return ducts and clean or resize as necessary. B. Increase supply airflow by boosting fan speed. C. Close some supply dampers to balance pressure. D. Reduce the outdoor air intake to compensate. Answer. Correct answer. B. Explanation. Low return airflow causes zone negative pressure, which can lead to infiltration, discomfort, and system inefficiency. Inspecting ducts for blockages or undersizing and correcting them addresses the underlying problem. Increasing supply airflow without correcting return duct restrictions may worsen imbalance. Closing supply dampers reduces comfort and does not fix return issues. Reducing outdoor air may temporarily stabilize pressure but undermines ventilation and IAC compliance. Question 20. Through the lens of an HVACR inspection, Taylor notes that an evaporator coil shows corrosion and minor leaks around several brazed joints in a commercial refrigeration unit. What is the most appropriate course of action? A. Repair the leaks with proper brazing and replace affected sections if necessary. B. Ignore minor leaks as long as system pressure is normal. C. Increase refrigerant charge to compensate for leaks. D. Replace the entire evaporator coil immediately. Answer. Correct answer. C. Explanation. Minor leaks and corrosion at brazed joints compromise system integrity and efficiency. Proper repair through brazing or section replacement ensures long-term reliability and prevents refrigerant loss. Ignoring leaks risks environmental harm and system failure. Increasing refrigerant charge temporarily masks the problem without addressing the source. Complete replacement is only justified if repairs cannot restore operation. Question 21. Given the circumstances, Mr. Franken is inspecting a commercial rooftop unit and notices high superheat readings at the suction line while subcooling is normal. The unit has E is still. What is the most likely cause? A. The TXV is malfunctioning and not feeding enough refrigerant. B. The condenser coil is partially blocked by dirt. C. The system is overcharged with refrigerant. D. The outdoor fan is running too fast. Answer. Correct answer. A. Explanation. High superheat with normal subcooling indicates insufficient refrigerant entering the evaporator, a typical sign of a malfunctioning TSV. A TSV regulates flow to maintain superheat, so a stuck or restricted valve will limit refrigerant supply. A blocked condenser or overcharge would alter subcooling and pressures. Outdoor fan speed affects heat rejection but does not selectively elevate superheat while leaving subcooling normal. Correct diagnosis ensures efficient and safe system operation. Question 22. From a practical standpoint, O'Neill finds that split system air conditioner is producing low airflow at the supply registers despite the blower running at full speed. Inspection shows no visible obstructions. What should she investigate next? A. Verify that the duct system is properly sized and sealed. B. Replace the blower motor immediately. C. Increase refrigerant charge to improve airflow. D. Adjust the thermostat fan setting to high. Answer. Correct answer. C. Explanation. Low airflow despite full-speed blower operation usually results from duct restrictions, leaks, or improper sizing. Assessing the duct system ensures proper airflow distribution and pressure balance. Replacing the motor without investigation may be unnecessary and costly. Refrigerant charge does not directly affect airflow in the duct. The issue lies in air handling design or obstruction. Fan setting adjustments do not. Structural or pressure issues in the distribution system. Question 23. While examining a heat pump, ISTA observes frost forming on the outdoor coil during heating operation, and the indoor temperature is lower than expected. What is the most appropriate corrective action? A. Reverse the reversing valve to cooling mode. B. Inspect and ensure proper defrost cycle operation. C. Increase indoor fan speed to compensate. D. Recover and replace refrigerant with a low pressure type. Answer. Correct answer. B. Explanation. Frost on the outdoor coil during heating is typical at low ambient temperatures. A properly functioning defrost cycle ensures the coil defrosts at intervals, maintaining heat output. Reversing to cooling mode would worsen heating loss. Increasing indoor fan speed does not remove frost. Refrigerant replacement is not required unless system pressures indicate a charge issue. Maintaining defrost cycle operation is essential. Efficiency and system longevity. Question 24. In the context of a residential gas furnace inspection, is seeing notices yellow flames and soot accumulation on the burners. Carbon monoxide readings are elevated. What is the safest and most compliant course of action? A. Adjust burner air shutter and schedule maintenance. B. Reduce gas pressure to the furnace. C. Replace the furnace immediately. D. Ignore the soot as minor accumulation is normal. Answer. Correct answer. D. Explanation. Yellow flames, soot and elevated indicating complete combustion, creating safety hazards. Adjusting burner air shutter and scheduling maintenance ensures proper air-to-fuel ratio, eliminating safety risk and ensuring compliance with combustion safety standards. Reducing gas pressure without adjustment may worsen incomplete combustion. Furnace replacement is unnecessary if adjustment and maintenance restores operation. Ignoring these indicators violates codes and endangers occupants. Question 25. While analyzing a chilled water system, Mr. Martinez notes that the temperature differential across several terminal units is lower than design, despite normal pump operation. What is the most appropriate next step? A. Check and adjust flow balancing at each terminal unit. B. Increase the boiler temperature to force better DT. C. Replace the terminal units immediately. D. Reduce flow at the pump to correct the differential. Answer. Correct answer. B. Explanation. Low DT across terminal units often indicates improper flow distribution or insufficient water temperature. Adjusting flow through balancing ensures each zone receives proper cooling. Increasing supply temperature may temporarily improve DT but does not address underlying flow issues. Replacing terminal units is unnecessary if the problem is distribution. Reducing pump flow without balancing may exacerbate temperature imbalances. Proper hydronic balancing ensures energy efficiency and occupant comfort. Question 26. When considering performance testing of a commercial refrigeration system, ISTAN measures and usually high subcooling and low superheat. What does this suggest about the system? A. The system is undercharged with refrigerant. B. The expansion device may be overfeeding refrigerant. C. Airflow over the condenser is too high. D. Compressor motor speed is too low. Answer. Correct answer. C. Explanation. High subcooling and low superheat indicate excessive refrigerant flow into the evaporator, often caused by an overfeeding expansion device or reduced evaporator load. Excessive airflow over the condenser can lower condensing temperature, artificially raising subcooling. Undercharge reduces both pressures and capacities. Compressor speed affects capacity but would not selectively create this pressure-temperature profile. Correct analysis ensures accurate diagnosis and prevents unnecessary system modification. Question 27. As illustrated by a recent inspection, Mr. Evans observes that a rooftop unit is tripping the high-pressure safety switch during peak summer conditions. Airflow across the condenser is normal. What is the most likely cause? A. Low refrigerant charge causing pressure spikes. B. A failing condenser fan motor. C. Outdoor ambient temperature increasing condensing pressure. D. Expansion valve stuck open. Answer. Correct answer. A. Explanation. Low refrigerant charge can cause erratic pressure behavior and high pressure trips due to improper heat absorption in the evaporator, leading the compressor to overwork. Normal condenser airflow rules out fan failure. High ambient temperatures contribute to higher pressures, but typically within design limits. An expansion valve stuck open would reduce high side pressure rather than trigger a high pressure trip. Accurate diagnosis ensures safe and efficient operation. Question 20. During an inspection of a ductless mini-split system, Ms. White observes low cooling capacity on one indoor unit, while others operate normally. What should she evaluate first? A. Check the refrigerant piping and balance of the branch circuit. B. Replace the underperforming indoor unit immediately. C. Increase system refrigerant charge. D. Adjust the thermostat fan settings. Answer. Correct answer. D. Explanation. Uneven cooling among indoor units typically results from branch piping restrictions or flow imbalances. Inspecting refrigerant lines and verifying proper branch circuit balance identifies the root cause. Replacing the indoor unit without diagnosis is premature. Increasing refrigerant may worsen the imbalance. Adjusting fan settings does not address refrigerant distribution and airflow at the branch level. Correct inspection ensures performance and prevents unnecessary replacement. Question 29. In the context of A commercial air handling inspection is de Jong finds negative pressure in occupied zones due to low return airflow. What is the most appropriate corrective action? A. Inspect return ducts for blockages or undersizing and correct as necessary. B. Reduce outdoor air intake. C. Close some supply dampers to balance pressure. D. Increase supply airflow by boosting fan speed. Answer. Correct answer. B. Explanation. Negative pressure results from insufficient return airflow. Inspecting return ductwork for blockages or undersizing ensures proper pressure balance. Reducing outdoor air may temporarily stabilize pressure but compromises ventilation and IAC compliance. Closing supply dampers reduces comfort and does not address the cause. Increasing fan speed without addressing return restrictions can worsen the imbalance. Correct duct inspection. Repair is consistent with building codes and HVACR best practices. Question 30. Through the lens of system inspection, Robinson identifies corrosion and small refrigerant leaks at brazed joints of an evaporator coil. What is the most appropriate course of action? A. Repair leaks using proper brazing techniques and replace sections if needed. B. Ignore minor leaks. A normal operation continues. C. Increase refrigerant charge to compensate. D. Replace the entire evaporator immediately. Answer. Correct answer. C. Explanation. Leaks at brazed joints compromise system efficiency and environmental safety. Properly repairing leaks or replacing affected sections ensures long-term system integrity. Ignoring leaks risks refrigerant loss and environmental non-compliance. Simply adding refrigerant masks the problem without addressing the leak source. Full replacement is only warranted if repairs cannot restore safe and efficient operation. Maintenance preserves system reliability and performance.